Refraction through a prism. Figure shows the passage of light through a triangular prism ABC. The angles of incidence and refraction at the first phase AB are I and R1, while the angle of incidence from the glass to air at the second phase AC is R2 and angle of refraction or emergence is E. The angle between the emergent ray RS and the direction of the incident ray PQ is called the angle of deviation. It is denoted by del. In the quadrilateral AQ and R, two of the angles at the vertices Q and R are right angles. Therefore, the sum of the other angles of the quadrilateral is 180 degree. So, angle A plus angle Q and R is equals to 180 degree. From the triangle Q and R, R1 plus R2 plus angle Q and R is equals to 180 degree. Comparing these equations, we get R1 plus R2 is equals to capital A. This one is equation number first. The total deviation del is the sum of the deviations at the two faces. So, del is equals to I minus R1 plus E minus R2. That is, del is equals to I plus E minus capital A. This one is equation number 2. From equation number 2, we know del is equals to I plus E minus A. So, we can say angle of deviation depends on the angle of incidence. At the minimum deviation dm, the refracted ray inside the prism becomes parallel to its base. So, we have del is equals to dm and I is equals to E, which implies R1 is equals to R2. Equation R1 plus R2 is equals to A gives 2R is equals to A or R is equals to A by 2. This one is equation number 3rd. We know del is equals to I plus E minus A. That one is equation number 2. In the same way, equation number 2 gives dm is equals to 2I minus A or I is equals to A plus dm upon 2. This one is equation number 4. The refractive index of the prism is N21 is equals to N2 upon N1, that is refractive index of medium 2 with respect to medium 1 is equals to sin A plus dm upon 2 divided by sin A by 2. This one is equation number 5. The angles A and dm can be measured experimentally. The refractive index of prism is given by equation number 5. For a small angle prism, that is a thin prism, dm is also very small and we get refractive index N21 is equals to sin A plus dm by 2 upon sin A by 2 is equals to A plus dm upon 2 divided by A by 2. And dm is equals to N21 minus 1 into A. It implies that thin prisms do not deviate light much.